question is coming with some idea. Every question comes with idea. Uh, you, there's a small question. We'll take this one here. Okay, read the question. I'm just magnifying it. A light uniform string is tied between ceiling and the floor, keeping a spring vertical as shown. A bead of finite mass is glued at a distance L from upper end of spring and then allowed to move gradually downward. The bead shifts a distance y to come to in equilibrium. The experiment is repeated for different values of L. What is L? At a distance L. Which of the following graph shows the best dependence of y on L? Just know what you learned, you should apply. Just know what you learned, you should apply. Okay, this is the spring. Natural length of the spring, how much it is, that is telling L. This is a length. So now I'll take a bead. I'll bring it here. So let the distance of this be L. It is like this. Huh? Now. Okay, there's a particle. So now the particle will get displaced like this. No, what actually? So let this be the displacement. What all question given, I just drawing the diagram related to that. The bead shifts the distance y to come in equilibrium. No, how many springs you see here? You see the upper part and the lower part, no? So, and we know that the spring constant depends on what? There's a basic formula. What is the formula? The spring constant depends upon the length, no? Length of the spring. So when you connect a bead, this will become upper part, this will become lower part. So now the spring got elongated. So now look at this one. What is L? L is the length of spring. So I connected a bead. So there are now two springs what we see. So what about the upper spring? Upper spring will have spring constant K1. Lower spring will have spring constant K2. What is the state of upper spring? Got elongated or compressed?
Elongated.
It got elongated. What about the lower spring? Got compressed. So how the spring forces I had to show? The spring forces should be mg downward. So this is elongated. So spring force here K1y. Then what about this spring? Lower spring, it got compressed. No, how the spring force of this also should act? This should act vertically. This also. You can ask questions. Why you are showing two springs forces upward only? Is spring elongated? The spring force will act in such a way that the yes, upper spring is elongated, no? So K1y will act upward. The lower spring, what when it got compressed, then it wants to attain its natural length. So therefore, how the I think I'm helping you really with this particular diagram, sir. At least looking at this diagram, you should follow. I'll divide this upper part of the string, let it be K1, the lower part of string be K2. Both the springs will have same elongation, same elongation the upper spring should be equal to compression in the lower spring. So we'll agree this formula. So now K1Y. So it's in equilibrium, no? He's telling it's in equilibrium. The word he has brought it. So net force on the bead shifts at distance Y to come to in equilibrium. So the net force mg should be equal to K1Y plus K2Y. Now, what is spring constant? I give formula. It should be depends on what? Spring constant, Young's modulus, elastic constant. Y naught, I'll call it. A by the length. K1 length is how much? It is L. What is Y naught? Y naught is Young's modulus. Now elastic constant you call. Elastic constant of spring of material. This should be K2 should be equal to how much? Y naught A L minus L by 1. So let me take this. This will be mg. Y naught A Y by Y also we can take common. Y by L plus Y by L minus L. So let's solve expression for Y in terms of small l. That's what he's asking, which particular graph here. So this should be equal to mg Y naught A Y by 1 by L plus somebody please mute it. So there should be L minus L plus L by L into L minus L. So further mg by Y naught A equal to Y capital L by L into L minus L. So let's go for further. Mg minus mgl square whole divided by Y naught A. So what is the basic equation now? It will end up.
Sir, Y naught A also.
Mg, okay, this is L will come here. Huh? Some, yeah. Check it. So this I'll rearrange now. Mg by Y naught AL into L. Mg by one L should be here. Huh? No, this L will not be there. Here L will be there, and this is L square. So make it everything alpha L square minus beta L square. Which graph you pick up, anybody? Now you are familiar with this. Huh? Differentiate this. Check for maximum minima. Dy by dl alpha minus 2 beta L. Then further d square y by dl square should be equal to minus 2 beta. So d square y by dl square I got less than 0. So maxima exists or minima exists? Maxima exists. So now which graph I should pick up? So maxima exists in almost all 4, no? Anybody?
Well, the graph is parabolic, sir.
It's a parabola, no? That's why you must be familiar with the graph here. So option D you can pick up. Afternoon, 6 o'clock, we'll have a class. Still one best numericals are there, so that we'll discuss. This is about the only basics, no? It took time. Next, what all we discuss will be purely application based. Just logical thinking is needed. These are some basics. As a student, you find very difficult. It's not possible for student to really gather all these things. Teacher must stress before entering. Whenever you're discussing spring, no, first we should know overall the idea of spring. Now what we came to know, When you displace a spring, when both the ends of the spring are displaced, there'll be one point on a